Hi there people and welcome to this video. Today I'm going to teach you how to write a MATLAB program to solve a given equation using bisection method. First of all, let's take an overview on how does this method work. Well, if you look at this curve of f of x here, you will notice that the actual root of the function f is located between these 2 points, a and b. So if you take the average of these 2 points, you will get to this point here, namely the x subscript n, which I call it the numerical root. You will see that this point is somehow close to the actual root, but if you want to get even closer to the actual root, you can replace the a with the x subscript n and take the average of b and the new a and get to a closer location to the actual root. But why did we replace xn by a and not with the b? Because the actual point is located between x subscript n and b. You can know it by multiplying the f of a and the f of xn. If f of a times f of xn was smaller than 0, then the actual root is between a and b. So we would have to replace xn by b. But if f of a times f of xn is greater than 0, then we have to replace x subscript n by a, just like this diagram here. It's really simple, so let's jump over to MATLAB and do the coding stuff. So in order to do that, I just defined a float here. Instead of some specific number like here, usually we used to put we used to define the number of decimals here. Like here, it calculates the data till its 5th number of decimals. Here, instead of just 5 or whatever number, I just put this number to a string function of the value of these decimals here. All it does is it just inverts the number, like whatever number, like 6 or 7, to a string, and it puts it like here. So this is my function here, which gets these things as inputs: f, which is a function handle, a and b, the tolerance, which is used here, the maximum iteration, and the number of decimals. The number of decimals is like I want to perform my calculations, like I want to calculate the numerical root till it's whatever number of decimals, whatever number I put in here. And then I define this string here. So I'm gonna print the data of each iteration in this line with calling this string, which I defined here. And this is just my table header and a for loop for the bisection method, and just define the x subscript n, print the data, and check if the calculated x subscript n meets our requirements, and updates a or b as such, and just end this if here and end the whole for loop here, and it's done. It's just something like that. It's so simple. Now I'm gonna just solve an example with this function I wrote here. I have a predefined example here. I'm just going to evaluate this in the command center and check if the program runs appropriately. And there it is. We can see that the program does everything we want. And thank you for watching. Goodbye, everyone.